Hi, this is Angelo, the grumpy old IT guy. That's right, you heard me, the grumpy old IT guy. And welcome to my grumpy podcast, The Group By Clause. This is the final podcast in my beginning T-SQL podcast series. And each podcast has a demo or two or maybe more, so pay attention, guys. And by the way, there'll be two other series of podcasts, which I hope you'll find useful and helpful. Okay, there'll be the intermediate T-SQL topics. All right, and here we're going to cover procedures, functions, triggers, CTEs, which stand for common table expressions and cursors, then a powerful add-on to the T-SQL query, the intersect, accept, and merge operations. Then query plans. This is really exciting. It'll show you how the SQL Server query engine and optimizer will break up a query into steps to show you how the data is retrieved and what performance issues there might be. Then we'll also look at transactions, isolation levels, and locks. Okay, this is a very important components to maintaining what they call those ACID properties of a transaction. And finally, there's conditional looping logic that is part of the T-SQL language. We'll look at database security and then backup and recovery. What else will we look at? Well, in the advanced T-SQL series, we're going to look at SQL Server and XML and JSON. We'll take a really deep dive into analytical and statistical functions. Then we'll look at how SQL Server plays with R and Python. Okay, this is a very important skill to learn. We'll look at pivot queries, which are another analytical operation that you want to get under your belts. Then there's advanced table concepts like memory tables and partition tables. And then we dive deep into some of those tables like temporal tables and those memory tables and partition tables. Right, so the advanced table concepts kind of gives you the overview, and then we take each of the more important pieces, the temporal, the memory, and partition tables, and really go into it. And finally, we end up with replication. So a lot of good stuff to learn. Okay, so get ready to learn the grumpy way. Okay, so by now, for those of you who haven't seen any of my podcasts, you're probably saying, who is this grumpy old IT guy anyway? Well, that's me. I'm a published author and data architect with over 30 years of experience in BI, data architecture, data warehousing, and data modeling. And believe it or not, before that I was an electrical engineer. Now, in the last 10 years, I've also participated in several large-scale master data and data quality initiatives. And to support these, I've achieved CIMP certification in master data and data quality. Now, I do admit I love the Microsoft BI stack, and I've been using SQL Server for more years than I care to mention. Does anyone remember SQL Server 2000? Well, I go back earlier than that, and I can just hear all the moans and groans out there. You're saying, oh, this guy's dating himself. Well, that's all right. And by the way, BI stands for Business Intelligence. And lastly, I hold a master's degree in computer science from New York Polytechnic University and a bachelor's degree in electrical engineering way back when Pratt Institute had an engineering program. And yeah, those were the days. I really had a good time, met a lot of great people, a lot of great teachers too, and I learned a lot, and I goofed off a lot, I have to admit it. Oh, and by the way, little applause, yes, and now I'm the founder and president of grumpyolditguy.com, and I'll be bringing you Grumpy University at the fall 2020 this year, and we're really going to have some very interesting and detailed courses on the SQL Server BI stack. All right, so get ready to learn the grumpy way. So, what topics are we going to cover? Now, this is an interesting podcast that shows you the power of the group by clause. Now, we cover basic group by with a roll-up, group by cube, grouping sets, and grouping sets with empty sets. So what's so impressive about this particular clause? Well, this clause allows you to group result data by category columns. Like, for example, grouping sales by product category, product subcategory, and product name. Now, these groups repeat as the categories change. And additionally, within the groups, you can roll up or summarize values as you go up and down the data groupings. So, for example, if we're counting the quantity of products on hand, not only can we count numbers of each individual product, but also quantities by category, subcategory, etc., like product category and product subcategory. Now we can also roll them up the same result column instead of listing them next to each other. And also we can simulate a multi-dimensional cube by using the group by cube syntax of the group by clause. Okay, a lot of heavy stuff here, so just be patient and stay tuned. And lastly, we can define sets of data groupings or even empty sets by specifying the columns we want to categorize the sets by. Now inside the sets can be roll-ups or cubes or both. Now some of this might sound confusing, but the demos will clear things up. Let's take a look at where the group by clause appears in this syntax tree. There it is. It's right between the where clause and the having clause. All right. Now, as stated earlier, we have these flavors of the group by clause. There's just a plain vanilla group by. There's the group by roll up. And then there's the group by cube, grouping sets, and empty grouping sets. And this is what we're going to discuss in this podcast. Now, these features come in handy when doing analysis on inventory or sales data or any other type of data, really. Now, after this podcast, you'll see how powerful queries can get when you combine a group by and an order by clause in your query. And I'll sneak in some aggregate functions along the way, which will be covered in my intermediate T-SQL podcasts. And I think we already covered them a bit in podcast 5, T-SQL DML. Now, by the way, the having clause is like a where clause for the group by clause. We use this to add filters to the rows returned by the group by clause. Now, here's a query that uses an aggregate function called sum. The group by clause needs to list all the columns in the select statement except for the aggregate function. Now, a specification for this query or report, if you like, could be show me the total sales amount by customer name and product name. Sort the report by customer name and product name in ascending order. And here we see that the data we need is in 3 tables. We've got the product table, the invoice table, and the customer table. Now this means we need to join all 3 tables via the common columns or keys. So invoice gets joined to product via an inner join on the product ID column, and invoice gets joined to customer via an inner join on the customer ID column. Now notice the use of the table aliases. This is easy. And if you're fuzzy on joins, please see my podcast, Grumpy Podcast 05 T-SQL DML. But now let's look at the group by clause. There it is. Group by inventory, INV, the alias, customer ID, then cus.customer name, and inv.product ID, and finally prd.product name, right? So all the aliases for those 3 tables. And notice also that the same columns in the group by clause are the same let's say, counting columns in the select clause, right? Anytime we have some sort of an aggregate function like the sum function or any other function like count or min-max, then all the columns in the select clause, except for the column that we're doing the aggregations on, have to go in the group by clause. And then we just order the results by customer name and product name. So this is a plain vanilla group by clause. It's very basic, but it works. Okay, let's go into our first demo and let's see how this group by clause works. Okay, here comes SQL Server Management Studio. We're going to use the Hobby Shop database. So there it is. We are in the correct database, so we don't have to execute that use Hobby Shop command. So here's our first little query. We're going to select Notice I commented out the distinct. We're going to try that in the next query. But I'm selecting the customer ID, and then I'm doing a count star as to the number of transactions, and then I'm summing up the total price and calling it total sales. And this just comes from one table, the sales.invoice table. Recall that sales is the schema name. So we're doing a group by customer ID. That's the only function, the only column there that we're not doing any counting on. And we're ordering by the customer ID. So let's see what this yields. Okay, pretty good. We've got the customer ID in descending order, right? Customer 5, 4, 3, 2, 1, etc. Each has 5 transactions, and there's the total sales. Okay, so, no big deal, but it does show you how it works. Now, what about that distinct? All right, I want to make sure that there's like really no, duplicate data in there. So a good way to check is by adding the distinct customer ID keyword there. And by the way, I can go ahead and, maybe just relabel this as, I'll call it, customer, whoops, if I can spell right, customer ID, just stick a space in there to be consistent. And yes, a capital R. Let's try it again. So same query, just putting in the distinct. And I'm going to execute both of them at the same time. So let's take a look down here at the results. So all the results are the same, except I believe I neglected to say that I'm ordering by customer ID in ascending order. So I get 5 rows in each, so it doesn't look like I have any problems with duplicates. What else are we going to do here? All right, we're going to take the average total price across all the transactions. So I'm going to select that distinct customer ID again. I'm going to use count star so we get the number of transactions. Then I'm going to use a new aggregate function, the AVG. This will calculate the average of the total price across each customer. I'm converting it to a decimal 10,2, all right? And finally, I'm pulling it out of the same table, the invoice table, grouping by customer ID, ordering by customer ID in descending order. Let's execute this query. So there it is. Again, 5 transactions per customer, and then the average total sales for all the customers. Okay, let's do this again. And what we're going to do is add a filter. All right. I'm going to introduce the having clause. So pretty much the same query, except that within the group by and the order by, I'm going to introduce this having clause, which is like a where clause for queries that use group by. And it's pretty simple, having average total price greater than 1,000. All right, so let me execute both of these at the same time. And let's take a look at our results there. And there it is. We only have 2 customers that have an average of a total price greater than 1,000. All right, so this was a pretty interesting query. Well, some of the smarties out there might be saying, hey, can I embed these aggregate functions? Like, for example, can I take the average of the sum of the total price? Okay, looks like something we might want to do. You ready? Here it goes. And oops, no, the answer is no. You cannot perform an aggregate function on an expression containing an aggregate or a subtotal. All right, so who knows how we can get around this. But that's it for now. Let's just get back to our clip, and we'll continue with group by with ROLLUP. Now things get interesting, real interesting, all right? And by the way, we're going to use a model train hobby shop scenario. And there's a little disclaimer, by the way, just all customer names are products of my imagination, okay? So they do not represent anyone living or dead, as they used to say in the old movies. Now we're going to roll up the groups of results by customer and product. What this means is that we're going to calculate the total sales by customer and product, and then for each customer and product, we're going to sum everything up. All right? We're going to sum everything up by each group. So for example, if we sum up all the sales on products for Acme Hobby, we get a subtotal roll-up of $4,200, all right? And if we sum up all the sales on products for Central Hobby, we'll get a subtotal roll-up of $2,335, and so on for each customer and product group. And then if we add all of these roll-up subtotals, we'll get a total sales amount of $46,325, right? So pretty cool, I think. And yes, it's time for another demo. So let's try this group by with ROLLUP. And here we are, SQL Server Management Studio once again. And let's scroll down here a little bit. We're in the correct hobby shop. Okay, now the queries start to get a little bit more interesting and complex. Let me put a little tab here so it's obvious where the joins are. And you may or may not like my coding style, but it's always good to adopt some sort of a coding style to make these queries as legible as possible. So now the query is just an adaptation of the other one. We're going to select the customer name from the customer table, the product name from the product table. Then we're going to sum up the total price from the invoice table and relabel it as total sales. And there's our joins. We're going to join the sales.invoice table. Notice the aliases. We're going to join it to the inventory.product table over the product ID. And then we're going to join the sales.invoice table again to the sales.customer table over the customer ID. And there's that group by ROLLUP. And we just supply the two columns, customer.customer name and product name. And for good measure, we'll sort it by customer name and product name, all right? So let's highlight this query here, execute it, and let's take a look at this data. All right, let's scroll this down so we can just refer back to that group by ROLLUP. So there it is. So notice we're rolling up by customer name and product name. All right, so there you see for the first customer in row 2, Acme Hobby Shop, $4,200. That's the roll-up of all the individual product sales. Then that same pattern, if you will, is repeated for Central Hobby Shop. Right, the roll-up is $2,335 all the way down the line across all the hobby shops. And then the final roll-up is there at row number 1, $46,325 for all the total sales. So you're seeing here now a fairly powerful query construct by doing this group by with ROLLUP. Now, whoops, let me go back here. And so some of you might say, wow, all those nulls, all right, I sort of get it. But if you're new to it, you might not. So all I did here is take the same query, so I won't go over it again. I actually just introduced in the group by ROLLUP the product type just to make things interesting, all right? So looking at the bottom of the query, I'm grouping by ROLLUP customer name, product type, and product name. Now, shame on me, I'm not being too consistent here. I'm using square brackets. I don't really need them in this case because there's no spaces with the names, all right? But coding style, again, counts. Now, the select clause is going to be interesting. I'm going to put some case statements so that when we get nulls, we'll put in some information so we'll know what the roll-up is. So the first case statement is when customer name is null, then just print out roll-up by customers. Otherwise, just use the customer name. And then for the second case statement, when product type is null, all right, then put in a roll-up by a product type. Or I should say when product type is null and customer name. So we got a condition here. When both of these are null, then roll up by product type. Otherwise, use the product type. All right, so let's see how this works. I'll select the whole query. See, notice the queries are getting a little complex too, right? So there it is. So now it's a little easier to read, I think. Notice customer name, roll up by customers for the first row. Everything else is null, and there's the total sales. So there's the roll up by customers. Then in the next row, all right, we have roll up by product type. So for each of the product types, PT02, PT04, etc., we're going to have roll-up values. For Acme Hobby Shop, by type is 4,200. And then for product name, I didn't include that. I should include one for product name. But you get the gist of it, is that you can just add these and it'll make the report a lot easier to read. All right, so let's see, is there anything else? No, let's go to our next topic. So next is the cube feature. Now here we can simulate a multi-dimensional cube, much like SSAS. And by the way, SSAS stands for SQL Server Analysis Services, which is Microsoft's cube engine. So if you think these queries that I'm about to show you are powerful, wait till you take a look at SSAS. Now getting back to the query, we include the word cube right after the group by clause, as in group by cube. Then you define the dimensions by identifying the columns, right? So a dimension is a type of column. And typically the term dimension is used in data warehouse databases. Okay, so what this means is that I can calculate subtotals and totals for every combination of categories or grouping columns in the group by clause, right? So if my T-SQL query calls out customer name and product name, I can calculate sales totals for each grouping of customer and products, each grouping of customers only, each grouping of products only, and totals for everything, no grouping specified. So again, a lot more query power. And here's the cube results, all right? It's every possible combination of summing up, you know, again, by customer name only, by total of everything, or by customer name and product name, right? So the more of those dimensions you add, the more, you know, different cube results you're going to get. Now, I'll say that understanding multi-dimensional cubes takes a bit of time. So let's just go into a demo and hopefully it'll clear things up. Okay, here we are in SQL Server Management Studio. Let me scroll down to our next topic there, topic 03, group by with cube. Once again, I'm a little too quick on the draw here, but use Hobby Shop, clear out the result pane. Okay, actually I went down too fast. This is grouping sets. We want group by and cube. Okay, here we go. So same query, basically select, you know, the customer name and product name, and then calculate total sales by summing up the total price from the invoice table. There's those three joins. And there's the new part of the query, group by cube, real simple. Put customer name and a product name. Let's see, let's go to this product table, inventory product. Let's make it more interesting. I'm going to add in here, right over here, I'm going to add PRD dot, a product type. Okay, little on the fly here modification. as, I'll call it product type. Okay, then in a little comma, then I'm going to take the product type column here and put it right after customer name in my group by cube section there. Add the column. Let's see what we get. We'll select the whole query. So there it is. There's a pretty interesting query. Notice the top row, the first row, we get the total, the grand total sales, 46,325. Then we get aggregates by product type. So you see product PT01, product type all the way down to PT04, and you see the sums for those. And then we see finally by product name the sum of all the different products and the total. So for example, across all customers, HO gauge diesel locomotive sales are 7,875. Notice there's no customers. Well, let's scroll down. Now we get the cubes, the cube roll-ups or the summaries by customer, for example. So Acme Hobby Shop, there's that 4,200 again. And then we get Acme Hobby Shop by product type, 1,450. And now the product type changes. We get 2,750 for product type PT04 for Acme Hobby Shops. And then finally, we just get all, the individual sales for the electric locomotives. Again, so it repeats. For the electric locomotive product, 750 sales, and that's product type 02, and so on and so forth. So you're getting it, right? It's every possible combination of aggregations across those dimensional columns. So again, dimension is a term used in data warehousing, and customer name, in this case, product type and product name can be considered dimension. So it's pretty evident. And I actually ran ahead of myself. I didn't need to do that typing. I added the product type here, so we don't even need this query. I'm just going to get rid of it. And no need to repeat things. All right, let's go look at grouping sets. So next we discuss grouping sets. Now this is a simple mechanism that allows us to include roll-ups or cubes or both in our group by clause. Now the syntax is simple. We just state group by grouping sets. Then within the parentheses, we have other sets of parentheses, set 1, set 2. So notice in our little query here, we've got a grouping set that includes a roll-up by customer name and product name. And the second grouping set is a cube by customer name and product name. So you're combining both roll-ups and cubes. Now, just again to restate it, each set can be a cube or a roll-up or both. And a word of caution, the resulting report can become very complex to read and understand. All right, so maybe some of those case statements to kind of spell out, what you're looking at, what kind of roll-ups you're looking at. And then, there's the grouping set results. Again, just combined the roll-ups and the cubes. So again, we see the grand totals. Then we're getting two grand totals, right? One is a grand total because of the roll-up, and one is a grand total over there because of the cube. And then it repeats itself across any combination of those dimensional columns. In this case, we're lucky there's only two, customer name and product name. All right, this is a kind of a confusing concept now, so let's get right into a demo grouping sets. Okay, here's SQL Server Management Studio, grouping sets. And let's scroll down a bit here. All right, pretty much again, same query. Let me pretty it up here so that the joins are fairly obvious. And legibility counts. All right, a little double indentation here. And sometimes people might like to either, even put a blank line, right? If things get a little, complicated, put in some white space, or maybe, a comment that says, here's the join section and here's the group by, but I'll leave that up to your imagination. So there's the group by grouping sets. So now we have that grouping keyword sets, and there it is. We've got two of them. All right, group by grouping sets roll up, and then there's set one. We're rolling up by customer name and product name, and then we're doing a second grouping set. We're doing a cube across customer name and product name, and then we're just doing an order by. Let me do something here. I'm going to get myself in trouble, but a little more cutting and pasting, or copying and pasting. New query window. Let's put this over to a new vertical tab group. And what I'm going to do is I'm going to take the cube one. Actually, what I'm going to do is I'm going to comment it out. Okay, so let's just do this. Put a comment here and a comment here, and just kind of compare results. So we'll execute this query that has the group by sets, the roll up, the grouping sets, the roll up in the cube. And here comes the results. Let me scroll this up here. And this time let's just do this one with only the roll up. All right, so we get slightly different, or different results here. All right, we've got 66 rows in the first query and 28 rows in the second query. So we see that we have a lot less combinations. We do have the double total sales, one for the roll up and one for the cube, whereas in the second query we only have the one for the let's see, what was the roll up. I commented out the cube. So you get the idea. You can just do any kind of permutation that you want. Now let me go back here, and this time I'll do the opposite. I'll comment. Let's see, I'm going to put a comment around this. Okay, and I'm going to put a comment here. Let me get rid of this one, and I'm going to take this one out. All right, so that works. All right, make it neat, obvious what's being commented out. Again, just make everything stand out, and then let me re-execute the query. So again, different combinations of cubes and roll-ups depending which way you go. If you really want to be, compare things, okay, I can just copy this again, or I'll copy this whole query, and I'm going to have another query window, put it over to the new vertical tab group. Let's make some. So I'm showing you too, when you're doing analysis, and especially when you're learning, right? This is the kind of stuff that you need to do, and take your time and just pretty much analyze things, right? I'm going to comment this cube one again. All right, so now you can see, you can compare when you have the roll up, when you have the cube only, and then when you have both of them together. So if I execute this one now, whoops, incorrect syntax. What did I screw up here? Comment is in the wrong place. Okay, this should do it, hopefully. But no, the little red line says I'm still messing this up. So what did I do here? Okay, we want this out, and we want to comment this out. And I have a little, actually I should have I'll put the comma here, and I'll take this one out. So very easy to embroil yourself here, get yourself all jammed up. But that's the point I'm trying to make, right? It's especially when you're learning this, kind of compare all the outputs, see how different they are depending on the combination, right? So that's it. I think that concludes this demo for this topic. Okay, and yeah, what's next? Grouping sets with empty groups. Okay, see you back in the clip. Hey, topic is 005, grouping sets, empty group. Now lastly, you can include an empty set in your grouping sets by including a pair of opening and closing parentheses with nothing in them. So check out the syntax in the clip. Group by grouping sets, customer or cus.customer name, prd.product type, prd.product name, and lastly, a set of empty parentheses. Now this will return the total sales by customer, product type or by product, and a grand total of all of the sales. It will not return any total sales for the customer and product groupings. So the best way is to get an understanding of this is to play around with it. Execute it, change it, and see how different combinations work and what results you get. All right, so there's that trick again. You just kind of, well, I line things up here just to look at the different combinations of data here. But here we included an empty set, so we can specify the categories, for the totals and subtotals. Now, notice in the left-hand side of the output, there's that TBD, all right? That's when I didn't have the product type defined. So I loaded up the product type table, and now in the right output, you see that there's also roll-ups with product types. So best way, again, is to just look at a demo and see how this works. Okay, good news, gang. Last demo, and I can now hear the cheers out there. So let's see what empty groups look like. And here comes SQL Server Management Studio. Topic 5, grouping sets with empty groups. So there they are. There's the query again. Let's format it. Okay, make sure you can follow along here. Try to make this as neat as possible here. And we got a lot of joins going on here. We got three joins. We're joining the invoice table to the inventory table, and then we're joining the invoice table to the product type table, and finally we're joining to the customer table right on inventory. Actually, invoice customer ID equals customer ID. Let me go through these again. The aliases need to help here because I've got an invoice table and a product table, and I'm pulling it out of the inventory schema. So let's go over this again because I confused myself, I'll admit it. So we're going to pull out some columns. We're going to sum up the invoice total price. So there's the first table, sales.invoice, and we're joining it to the product table in the inventory schema. So we're doing this on the product ID. And then we're going to join to the product type, and we're going to do this across the product type column in the product table and the product type table. That makes sense. And then finally, we're joining to the customer table. So we're joining the invoice, the column customer ID, to the customer ID in the customer table. Okay, say that fast 3 times and see what happens. All right, there's our group by grouping sets. We're grouping by customer name, product type, product name, and then there's that empty set of parentheses. So let's just execute this and see what we get. Let's examine this data. Let's see the permutations that we get. So we have $1 grand total sales, and notice there's no customer name, product type, or product name. So there's our empty set. Then we have only product names listed from, let's see, rows 2 through 11. with the amounts, the sums of the HO gauge diesel locomotive sales and HO gauge electric locomotive. Then our next set is just the product types, so we have all the summing up across product types. And finally, as you can see, the customer name is last, so all the summing. So they're all individual, right? You're not going to see like permutations of customer name and product type, or customer name and product name, and so on and so forth. So hopefully that's clear. Now we got another query here which I modified. Let's look at this versus no empty sets. Let's see what we get. I'm going to do our little trick here, copy and paste. Let's do a new query window. Let's make sure it's over in a new vertical tab group. Let's paste it. Let's run it. All right, let's kind of compare the results here. All right, so they actually look the same. All right, so by getting rid of that empty set, actually they're not the same. I take it back. What's missing? Well, what's missing is that first row over on the left-hand side, right? We don't get any total sales. So notice by removing the empty set, right? Oops, let's go back up here. By removing that empty set up there, we're not getting the grand totals. Let's see what else we have down here. I revised the query. Oh, no, this is just a backup for this script. So there it is. Good news, everyone. We're pretty much finished with our demos, so we can go back and wrap things up. Okay, I hope you agree that this was an interesting podcast. It did show the power of the group by clause. And we covered the basic group by clause, then group by with roll-up, then group by with cube, then grouping sets, which was pretty interesting, and grouping sets with empty sets. Now we learned that this clause allows you to group result data by category columns. Like for example, grouping data by product category, product subcategory, and product name. And additionally, within the groups, we learned that you can roll up or summarize values as you go up and down the data groupings. So next we learned that you can also simulate a multi-dimensional cube by using the group by cube syntax of the group by clause. All right. Now lastly, we learned that we can define sets of data groupings or even empty sets by specifying the columns we want to categorize the sets by. Now inside the sets, we can roll up or do cubes or do both. Okay, so that wasn't hard, was it? And by the way, I did throw out some terms here, cube and multi-dimensional. Now for some of you who probably aren't too familiar with that and might be familiar with the spreadsheet concept, imagine a spreadsheet, but that you have in the first, we'll call it tab of the spreadsheet, you'll have sales by product and customer. And then right behind that, you're going to have another tab called sales by, let's see, product and region. And then yet another third tab right behind there, sales by salesperson and store. All right, what a cube is it allows you to look at those different views by just generating the data on the fly. And we generated this on the fly in a result set that was two-dimensional. You had to scroll down to see the different permutations. But if you look into something like analysis services, it's a very powerful cube engine that will let you do this analysis on the fly. But I'll leave that to my podcast on analysis services. Okay, I hope you enjoyed the podcast again, and I hope you learned the basics of the group by clause. So here's a list of my podcasts for the category of SQL Server tools. All right, there's podcast T01, Installing SQL Server. This is where we download, install, and configure SQL Server 2019. Then podcast T02 is Installing SQL Server Management Studio. Now I'm labeling it here 2019. It's actually SSMS, I guess, version 18. but I'm using it with 2019, so I called it SSMS 2019. But anyway, that'll show you how to download and install the tool. And we've been using it all along in all these podcasts. Then in T03, there's Installing Data Tools 2019. This installs a set of tools basically in Visual Studio so that you can create and manage SQL Server related projects. Now, if you don't have if you don't have Visual Studio, I should say, 2019, then podcast T04 is for you. It'll show you how to download and install Visual Studio 2019 Community, and yes, it's for free. Okay, I'm only showing you how to download and install stuff that's for free. And podcast T05 is Installing Reporting Services. That's the web-based architecture that complements SQL Server. It allows you to basically publish web-based reports based on SQL Server data or other data sources like spreadsheets and data files and even other database products. Basically, if you have a ODBC driver and you can connect to it, you can crank out reports on it. And finally, T06 is Installing Report Builder. This is actually the GUI, the tool you'll be using to create the reports. Reporting Services basically just supports the loading and the publishing of the reports. And finally, podcast T07, Installing Power BI, all right? Another advanced tool that allows you to create very slick and sophisticated dashboards and scorecards. So it pretty much complements this whole SQL Server BI stack architecture that's also suited very well for data warehouses and data marts, all right? So that's it. Let's wrap things up and let's see what other Grumpy podcasts I have made available for you for free. Okay, let's just review again the podcasts in my introductory series. So this is for you folks out there who haven't taken my my other podcasts. So I have 9 in this series, and the first one is Navigating SSMS. So if you've downloaded, installed, and configured SQL Server and then downloaded and installed SSMS, this takes you through using the tool. So definitely a very important podcast. Then podcast 2, 3, and 4 take you through creating databases, tables, and views with SSMS. Podcast 05 takes you through DML, T-SQL DML, Transact SQL Data Manipulation Language. So this is where you write queries or learn how to write queries against the data, but also we'll call them queries or statements that insert, update, and delete data in tables. Then podcasts 6 and 7 show you how to use string and date functions in your queries. Podcast 08 was the order by clause that showed you how to sort data. And well, podcast 09 is this podcast where you learn all about the group by clause. So that wraps it up, except for one more clip. And let's take a look at what's going to be in my next series of podcasts. Okay, here's a list of podcasts in my intermediate T-SQL series that's going to be available in the fall of 2020, right around September of this year. So we got a lot of interesting podcasts. There's 11 of them. The first 3, podcasts 10, 11, and 12, take you through procedures, functions, and triggers. Now, procedures are like little programs or unit of code that are named that you can call over and over again. And they basically contain T-SQL logic. And you can pass parameters to them, and some of those parameters you can define so that they pass back a modified value from the procedure. All right. Functions are like store procedures too, but they're different in that they actually return a value. So once you execute a function, it'll return whatever value you tell it to. And then triggers are like procedures or functions, but they execute automatically. So in other words, they execute on an event. Like, for example, if you insert a row into a table, you can create a trigger on that event. And that trigger usually has some sort of logging, right, that shows you, hey, on such and such a time, this row was inserted. And it could do a whole bunch of stuff. So there's triggers for update and insert and delete. Then there's podcast 13, CTEs, which stands for Common Table Expressions and Cursors. All right, these are basically code constructs that allow you to loop around sets of data and do some logic on them. Podcast 14 introduces intersect, accept, and merge, which think of back to high school days, all those algebraic functions. This allows you to perform functions, algebraic functions on sets of data. So for example, you can compare two sets of data and see what data is common and what isn't. Then there's query plans. Right, query plans show you the steps that the query engine will take to execute a query. Then there's transactions. All right, transactions we briefly covered in podcast 5. So transactions basically allow you to ensure that your data gets committed or rolled back in case the transaction fails. Then complementary to transactions are isolation levels and table locks. Really won't go into these, but you definitely have to take these podcasts. Podcast 19, condition and looping logic. So now we start to see the power of T-SQL. We can introduce if, then, else statements and while loops. So something definitely that you need to add to your arsenal of T-SQL tools. Finally, podcast 20, database security, how to create and manage user ID and passwords. And podcast 21, how to back up and recover your data. Okay, so a lot of interesting stuff now. So please do not take these podcasts until you've taken all of my podcasts in the introductory series. Okay, so see you in Grumpy Podcast 10 Procedures. And yes, here we go. Here's the applause. All right, please be on the lookout this fall for my Grumpy University at grumpyolditguy.com for a buffet of T-SQL courses to enhance your skills. And did I leave out that it's a savory buffet? All right, enough of the corny jokes. See you in Podcast 10, Procedures.